Hey everyone, welcome to my presentation, and thanks to Leslie and the rest of the PancakesCon group for putting this together. I'm really excited. This is my first PancakesCon as an attendee or as a speaker, and I'm loving it. Super cool. My talk is Under the Hood of SAST, how static code scanning works, and then we'll talk about the evolution of women's pro hockey. My name is Julie Davila, and I am presently the Vice President for Product Security at GitLab. And I've also shared my LinkedIn with all of you, should anybody wish to connect after this talk. A little bit of a deeper intro. My background is really as a Jill of all trades within the world of tech. I've done a little bit of everything. Started off as a sysadmin, have spent time doing cloud engineering work, software engineering work. I've done cyber R&D, worked a bit in big data, and kind of more, I consider myself more of a generalist or polymath versus being hyper specialized in any one role. And now I find myself at GitLab, where I oversee our approach to infrastructure security, application security, vulnerability management, and then there's a relatively small software engineering team that reports to me as well. Why hockey? Well, hockey's been a big part of my life since I was really little, since I was about 5 years old, and I've been playing ever since, for the most part, with a few breaks in between. And as sort of Mike said on the prior talk, this is my hobby. Hockey's my jam outside of work, and my sort of second full-time job, which is being a mom of two young boys, one of which is also playing hockey. And I'm also a veteran and based out of the DC area. So talking about the agenda, we're really going to cover kind of 4 things, if you will. So we're going to talk about kind of just SAST, introduce it, like what it is. I don't presume everybody knows what it is necessarily, though it has become increasingly popular over the past decade. I think it's come more at the forefront these days as software security and the supply chain security therein has become a more prevalent topic all around. Then we'll talk about how they actually work, right? Not in terms of how do you use it as a developer, though we'll talk about that a little bit, but really how it works behind the scenes and understand really kind of the logic that makes SaaS tools do what they do. And then we'll talk a little bit about what you should consider if you write software, whether you're an enterprise or a startup, what matters there in the context of scanning for security stuff. And then the second half of the talk, we'll talk about women's pro hockey and really kind of take a timeline view of that world from the late 1800s through the modern day. So very brief primer on what SAST is. SAST is what most people call it in the industry. It's really an important tool that helps you identify a certain category of security vulnerabilities within the software that you write. And that's an important distinction because there are other tools that help you identify vulnerabilities in software that other people wrote. And those are typically software composition analysis tools. And then there's other mechanisms as well. But that is really about the tools that you write. And the other interesting part of it is that it also helps detect a certain other sort of flavor of quality flaw, where in and of itself, it might not necessarily be a security concern, but overall leads you to have a code base that is just better all around. And then one of the interesting use cases that have come up in recent history as software security has become more and more regulated is the ability to use SAST within the context of compliance, right? So if you think about things like FedRAMP or HIPAA, or even some more like European regulations, SAST can help you be in compliance with some of those things. There are some inherent qualities to SAST that make it different than many other types of security tools that exist today. So for instance, it's a non-runtime tool. So what does that mean? That means it doesn't place a burden on your production workloads because it happens before production. It can happen as far to the left as your workstation, or it can happen right before you do the final check-in to prod in your CI pipeline. It's also really easy to get wide coverage. It functions not too different from a compiler. So generally, if you use it, use a SaaS tool, the tool itself will do a pretty good job at picking up everything that it needs to pick up with very, very little overhead, as opposed to, say, something like unit testing, where you kind of have to do the work yourself to ensure that coverage. The other nice thing about it is that it can detect flaws really early, especially if you do use it within the context of, say, like your IDE. And that just makes things a lot cheaper. And we'll talk about that more later. There's a lot of SaaS tools. It's a fairly congested market. There's really no wrong way to do it other than not doing it. And it really doesn't matter if you're doing it within the context of a startup or a side project, or you work for a large regulated enterprise. You probably should be using a SaaS to some degree. And some examples, right? GitLab, shout out to my employer, does SAST stuff within the context of our CI pipeline offerings. And then there's some open source tools like SimGrep, Bandit, Brakeman, etc., and as well as some other vendors. Again, it doesn't really matter as long as you use one that you're going to use consistently and that your teams are going to use consistently. So what does usage actually look like, right? This is going to be more familiar to people that have written software as their full-time job. And I really kind of categorize it into two buckets, right? One is within the context of your development environment, and that's kind of what we see in the grayish box to the right within VS Code, where as you write software, it can start highlighting problematic areas and let you know what the issue is, right? In this case, it's highlighting an issue with path traversal, within the context of a Node.js application. And then the other side is within the context of your CI tool. And I say CI tool versus CI process because you might be using a CI tool without the actual process. So whether it's your Jenkins or Circle CI, GitHub Actions, GitLab runners, it doesn't matter. Typically, SaaS tools will have some capability of integrating at that level. And again, the biggest value is going to be in early remediation instead of trying to fix these kinds of flaws after they've been introduced into a production environment. So I did make a note of doing this type of work to the left, and so just to level set, especially for folks that might be newer. Shift left is just the idea of doing a given software thing as close as possible to the part where you're actually writing the code, right? So your actual desktop, your IDE, whether you're using Vim, Emacs, doesn't matter. And the whole idea is that it's cheaper, not just in terms of dollars, but in terms of attention and the amount of people required to fix it. So the closest you can fix things before you actually make the pull request or merge request into the main line of your code, just the better the fix is going to be. So what do flaws look like, right? So I created a very contrived example of the precursor to a nice SQL injection vulnerability in which user input is taken in without any sort of sanitization and used in the process of concatenating a string that will then authenticate and make a database query all in line. This is not a good pattern. Don't copy paste this code. And SaaS tools are really good at catching these types of flaws. But let's backtrack a little bit and talk about what the main concepts within SAST are, right? So in SAST, you really kind of have two categories of stuff, right? On the left, you have sources, and sources are kind of anything that supplies the input to the logic that you wrote, right? So this could be the data coming in from a user submit form. It could be data as a result of a REST call that you make to a third-party network or whatever. It could be, your typical sysargs if you're doing like a CLI utility. Again, anything where untrusted input, if you will, makes its way into the code that you wrote. And then sinks is the place of execution, the place in which a vulnerability, if there is one, will be realized, right? So you can think about calls like your eval functions or your subprocess popen calls. This becomes the work, right? You want to trace the source to a sink and really identify the steps in between that lead you to a vulnerable place. In the very early days of SAST, we're talking, a decade or longer before then, there were some attempts to try to leverage things like, if you can think like grep or grep-like mechanics, where you kind of just do raw parsing of files. But that started to become a problem because if you just kind of grep something.py, for instance, you're also going to bring in code comments and other things that aren't really necessary. And at scale, it starts to become problematic to try and figure out all of the nuanced exceptions to the code that you're trying to scan. And then came lexical analysis, right? So lexical analysis is kind of very low level data as to how your software is written. And you can think about the enumeration of the particular row and column and area in which a particular piece of code exists. It's very verbose and very hard to reason about, not just visually as a human, but also programmatically. And those were really kind of like the early attempts. So then the industry, the open source community as a whole started kind of really centralizing their work around really imitating compilers in a way, right? And one of the big components of like compiler logic is the usage of an abstract syntax tree. So what is an abstract syntax tree? It's a representation of some code in a way that's hierarchical, right? So if you can take a look at the top right-hand side, we have a very simple function that just prints out hello to the console, given whatever name you supplied as input. And on the bottom right, we can see all of the nodes that are enumerated. And you notice the nodes that are enumerated aren't really talking about what the code does per se, but really how it's built and how it's put together, right? So you're able to kind of see all of the discrete components, everything from literals to blocks to kind of even identifying where in the logic does the root of the software you wrote lie. That being the program text you see at the very top of the bottom right box. Okay. Now, abstract syntax trees by themselves sort of give you the structure, but they don't really give you code flow in and of themselves. With ASTs, however, you can then go to the next step of maturity, for lack of better words, with this type of logic, and that's the ability to leverage call graphs. So call graphs, it's also known as semantic analysis, allows you to really understand the mapping between various functions within your app. So if we take this very simple graph represented on the right-hand side, B and C are both dependent on function A, and being able to map your software in this way now makes it possible to understand how data flows within your application and what variables are called where as they lie within that hierarchical map. Okay. Now, this is great, but then we need sort of one more step to really get the most amount of value from a given SAST tool. And again, these are patterns that are common across virtually every SAST tool. There are some that do things a little bit differently, but generally they follow this process. So AST, cool. With an AST, now you can do taint analysis or tracking, as some folks call it, right? So an AST in and of itself will tell you where variables lie, but it doesn't really tell you how variables are manipulated, right? So if you have a string that you concatenate, or it gets reassigned, or you modify the underlying object of that variable, a call graph in and of itself won't provide that for you. So then the logic is further enriched with the work of taint analysis. The other really interesting value with taint analysis is that it can also help you assess the impact of a code change in terms of functionality or if the logic is sound, right? So if you're doing a partial rewrite of a particular piece of software that your team is responsible for, taint analysis can also help you detect any sort of problematic areas as a result of sort of restructuring your methods and objects and all that kind of thing. Okay. Cool. So once you have those things, right? So once you have the AST, the call graph, and the analysis, now you have the stuff necessary to report the results. And the results, again, can be reported any number of ways. They can be reported within your terminal if you're using a SAST tool as a CLI utility. It could be represented within your IDE. Personally, when I wrote software more full time, I would use Vim, and I would just use SAST within the context of like my tmux, for instance. It was fairly simple to do. And then it can also be used in your CI pipeline, whether that's part of the merge or pull request, or later on as a sort of final QA step, especially if you have a lot of developers contributing to the same logical code path in a very condensed time period. Cool. So the hard work, the tedious work with SAST tools is that even though they come batteries included for the most part, generally if you download SemGrep or whatever, that you'll be able to use them right off the bat, and they'll be able to identify a certain class of vulnerabilities right off of the bat. And that's really useful, and it's better than nothing. However, over scale, and by scale, I mean if you have dozens, hundreds, thousands of software developers, you're going to frequently encounter situations in which it does not detect something out of the box, or where it detects things, but in a way that doesn't take into account the nuance of your environment or how your application works. And herein come in rules. So different SAST tools have different ways of expressing these rules. Here I show an example of SemGrep, where if you wanted to sort of explicitly identify the usage of subprocess with an active shell, which is generally not a best practice in Python land, on the right represents the YAML pattern used to detect something like this. So again, every sort of SAST tool will have their own differences. Generally, I advise software teams to kind of focus on the flaws that are more prevalent within their code base or recurring, if you will. So if a software organization happens to have a bug bounty program, for instance, typically you'll start seeing patterns emerge over time that'll help direct how much effort you put into custom detection rules. So summarizing how SAST works, right? There's really kind of two major parts. One being the code parsing aspect of it. You have the abstract syntax tree, which is kind of the natural evolution away from sort of that greppiness work of old. And that AST enables the instantiation of a data flow analysis or a call graph. And then with that, then you can start doing taint tracking, which then allows you to understand how variables change as they progress through the different logical components of your software architecture. And then one bonus item I didn't really address because it's not super common, but it does occur. There is another way of understanding how variables are sort of messed with over time, and that's single static assignment. And that from a high level is essentially at compile time, for lack of better words. It collapses all variables into a singular representation instead of sort of having to think about relabeling or the reassignment of objects. It just sort of takes a more black and white view over what a variable is and allows for a little bit better performance optimization. There's nothing wrong with it. It's not inherently worse or better than taint tracking. It's just a little bit of a different logical approach. And then the second part, right? Analysis, the actual taking of the parse results and analyzing them and telling you if there is a flaw with them, right? So you got when you have this, typically you are using it with other tools as well, like your SEA tools, or even other sorts of other scanners. And that's really kind of the two main components. Okay, so considerations at scale. So typically, when you're thinking about how I use SAST as an individual, you're thinking about it in the context of your workstation or your pull request or merge request. But when you're sort of providing SAST for a lot of developers, you need to start to need to optimize because things can start getting a little bit slow. And slowing the delivery of software for the sake of security isn't always the best trade-off. So anytime you can sort of reduce that tax on productivity, the better. So there's a couple of approaches. One is sort of I think of like parallelization on host. So think about like leveraging multiple threads. A lot of libraries do handle this really well, where they can sort of process different parts of your code base at the same time instead of doing them in sequence necessarily. But then there's also distributed analysis where you can have different machines work on different parts of your code base at the same time. This is going to be more common for enterprise software tools that are just, or products that are just really, really meaty and probably do need that distributed analysis in order to be able to be leveraged effectively. And even then, you'll have some test suites that can take hours to run. It just kind of depends on the scale of your organization. And then lastly, tuning and optimization. The bigger your developer footprint is, the more those custom rules and tunings and optimizations are going to matter. And the sooner you do them, the better. Because what tends to happen is if you leave a SAST tool, just like any other security scanner tool, unattended and let it make all the noise that it can make, developers can become overwhelmed and then sort of stop ignoring them. And you kind of end up with a boy who cries wolf type of scenario within the context of your software security, and you really don't want that. So it's really important to take into account developer experience when doing SAST. Other software quality tools that matter that I've pointed out, I won't talk about each of these individually, but these are all tools that can be leveraged not too differently from SAST within the in the sense that you can leverage them sort of locally on your device. Like you can do dynamic app testing on your workstation, or you can do it within the context of the CI pipeline as well. And I highly recommend leveraging all of them and leveraging them generally as far left as possible. But again, always letting pragmatism dictate how and where you test. Ultimately, you want to ensure that software delivery is optimal for your team. So I've also provided some resources on my slide deck, which I will share. Checkmarks and GitLab, we both have pretty good labs where you can dabble around with SAST if you've never used it before. If you just want to use get right into using it. I've also provided a few resources for folks that are especially nerdy. I've also included a link to a really interesting paper called Source Code Analysis, a roadmap, which kind of enumerates all the different ways in which source code can be analyzed. It goes into the different flavors of data flows, and this gets really deep into the weeds. So I'll leave those there for the group. Okay, so very abrupt segue. We'll talk now about women's pro ice hockey. So women's hockey, it's been around for a long time. The earliest documented occurrence of a woman playing ice hockey was Lady Isabel Stanley. So her father was Lord Frederick Stanley, who was the man who created the Stanley Cup, which then he gave to the NHL, and then that's kind of the cup that professional men compete for every year in the National Hockey League. So Lady Isabel was one of these first players. She participated in the very first women's hockey game ever, which was back in 1891 in Ottawa, Ontario. And this sort of triggered the start of women's hockey at the collegiate level across Canada, and pretty quite early on. They did this with minimal support from the men at that time. But even then, they still became incredibly popular, and they were defying societal norms, even though they had to play ice hockey with ankle-length skirts for quite some time, which would have been awful to do. I can't even imagine. So not too much later, I think less than 30 years later, we kind of had the real first, and I put in quote pros, which I'll explain in a little bit. The Vancouver Amazons were the first ever champions that won in February of 1921. This was a really interesting tournament in that they played it during the occurrence of a men's game or men's games. And the way they would play is in between periods of men's games, the women would go on the ice and have sort of shorter periods that they could fit in between the periods of the men's games. And that's how they would get sort of their initial audience, how they would get their ice time. And then they would play their final period after the men's games ended. And they did this, and there were three teams, right? The Seattle Vamps, Victoria Occupies, and the Vancouver Amazons were the three teams represented. And Vancouver was just dominant. They had a single point scored against them across the entire tourney of about 6 games or so. And as a result of that game, many of the women on the team lost amateur status. So that's an interesting thing to think about. So amateur status, especially during that time period, was a big deal because if you were a professional in one sport, you could not be considered an amateur in any other sport. So these women actually didn't intend to become pro, but the fact that their game occurred during men's pro games and that people had to pay to even witness them meant that they all got the label of pro as a result of playing, which meant that many of the women on the team who played other sports like swimming or track were no longer considered amateurs in those sports, and they decided to screw it in terms of those other sports that they were into and really just kind of double down on hockey, which is really cool. Then not too long later, came World War II, which reset things a bit. And there really wasn't a ton that happened with hockey from the 1940s until about 1966, which is when women's hockey really began in the USA. The very first collegiate team in the US were the Pembroke Pandas at Brown University. And that was the very first team that was formed. It's interesting to note, however, that even though there was college teams in the 60s, 70s, and beyond, there really wasn't a women's college championship until much, much later, and we'll talk about that later on. Another interesting point is that sometimes women pretended to be boys in the pursuit of gender equality within the sport of hockey. So, for instance, Abby Hoffman, one of the legends of early women's hockey, she when she was 9 years old, up to about 9 years old, she would pretend to be a boy, so that way she could play hockey because the closest girls' team was pretty far. But as she got older, it became harder to keep up the act. And then she eventually got kicked off that team and eventually found her way to hockey again later on, but within girls and women's hockey. And then there was Nancy Shiflin, who was one of the earlier pioneers of women's hockey, and she was one of the first pioneers of women's college hockey, specifically within the U.S. And to sort of convince the men that women were pretty damn good hockey players, she pretended to be a guy playing with the college guys, and did really well, and sort of helped elevate the posture of women within the world of hockey during that time period. A little bit afterwards, less than a decade later, the Ontario Women's Hockey Association was formed by Fran Ryder. Fran Ryder being the woman with the red button-up and blazer on the bottom right, and she's really responsible for making women's hockey official within the broader organization known as Hockey Canada. And it was this formation that then led to the first real international world championship for women's hockey. And by real, I mean one that goes beyond the US and Canada. So we talked about what happened previously with the Vancouver team. That was just US and Canadian teams, but with Fran Ryder's work, now we started seeing teams from Europe represented in the world of women's hockey as well. Somebody that I wanted to highlight, one of the sort of first stars in the world of women's hockey was Shirley Cameron. She established kind of the first competitive women's team in Edmonton, and ended up becoming really kind of a pivotal figure in that she was the first captain of Team Canada to compete at the International Hockey Federation level in 1990. And they would go on to win gold, I think about eight times consecutively. And she was a big part of that and at the forefront of that momentum for sure. Then we fast forward a little bit into the 90s, which were a really exciting time for women's hockey. In 1992, Manon Rhéaume played one period for the Tampa Bay Lightning, which is a men's NHL team, during an exhibition match. It was in reality, it was a little bit of a PR stunt in that it was used to elevate women's hockey and show that they could play. She did well, but again, it wasn't sort of like a real match. It was just like a for fun match. But even then, it was a big deal. She's the only woman to have ever done it, and I hope to see that again sometime in the future. Then about 6 years later, we got the Nagano Olympics. So prior to 1998, women's hockey was starting to make an appearance within the Olympic Games, but really kind of as just like a showcase or like a side sport, if you will. It wasn't a thing that you could win a medal on until 98. So Nagano was the first time, and the very first winners of that were the United States, which was really cool and really started, I think, really set off the rivalry between the US and Canada as far as women's hockey goes. Because prior to 1998, the only time the US and Canada had ever competed was on the international stage with IIHF, and Canada was winning all those matches. So then in 1998 is when you saw US sort of take the lead at the international level of competition. A year later, we had the sort of first real pro league, a pro league that people expected to be pro and not accidentally pro, as it were in the 1930s. The NWHL was primarily based out of Canada early on. There wasn't really any pay at all during this time period. Everybody certainly needed like an actual job on top of their hockey job. And but what it did is it really provided a framework for younger girls and women to be able to develop within the game and know kind of what was expected of them if they wanted to play at the highest level. So it really kind of standardized that trajectory early on. Then we get into the 2000s, and this is where we get like a little bit fancy. So the first NCAA Women's Hockey Championship was in 2000, won by the University of Minnesota at Duluth. They claimed the first title. Now, remember that the first college team in the US was in the 1960s. So it was almost 40 years before it got to the place where there was an actual championship associated with women's college hockey. But even then, that sort of set the standard. Minnesota Duluth, they continue to be a very competitive hockey organization and are consistently in the top 5 teams in recent history as well. The other thing to highlight here is that in 2005, we had something really remarkable happen in that the US wins the first women's world title against Canada. So if you remember, the US won the Nagano Olympics in 1998. So then it took about 7 more years before them they would win at the Women's World Championship as well. However, a year later, the Swedes beat the USA in the Turin Olympics. Sweden ended up taking second place behind Canada. And this was a really big deal because from pre-2006, the only teams that would ever win anything were the US and Canada. So the fact that a non-US Canadian team could win at the Olympic level was a really big deal and was cause for a huge celebration for the Swedes. And it was really spectacular to watch that. The US ended up taking third, Canada first, and Sweden in second place. So there are a few women that I want to highlight that were big deals. They were really part of the first group of inductees into the International Hockey Hall of Fame. It took them a while to get there in the sense that the Hockey Hall of Fame for the longest was a male-only award. And later on, I believe in the 90s was when the bylaws of the IIHF were revisited, allowing women to be on the Hall of Fame as well. So first one that's really well known in the US is Cami Granato. She played in every single World Championship from 1990 to 2005. She also led the US to numerous wins, including the very first gold medal that they won against Canada. So if you remember earlier, 2005 was the first time the US beat Canada in the Women's Worlds. She was the captain of that team during that time. And then I believe she was inducted into the Hall of Fame in 2010. Then we have Geraldine Heaney. So this woman is a machine. The fact that she was able to play 1,000 games professionally over a 27 season-long career is a remarkable feat of the human body. And during her time, she won 7 gold medals on behalf of Canada. And she was inducted a few years after Cami Granato in 2013. And an interesting story between Geraldine and Cami, back in the 1998 Winter Olympics of Nagano, when the US won the first Olympics for women's hockey, Geraldine and Cami were playing against each other. So interesting fact. We're both Hall of Famers, both were sort of part of the OG group of athletes there. And then we have Angela James, who is an absolute machine. She has an incredible story, having come up from a really underprivileged background, and in spite of that, still becoming a powerhouse in the world of women's hockey. She would typically play defense growing up, but even as a defender, would oftentimes be the leading scorer of her teams. Her pro career spanned almost 20 years, and she did lead Canada to gold along with Geraldine from 1990 through 97. So also a very big player and one of the very first Black women to play hockey as well, which is super cool because unfortunately hockey doesn't tend to be the most diverse sport. So she's definitely a pioneer there. Then we have the last decade or so. So the last decade has been really interesting. It's been a little bit of a mix in the world of women's pro hockey. The CWHL, or sorry, the NWHL, which we talked about previously, became the PHF, and those consisted of a number of teams. But then there was also a competing league, the PWHPA, and the way that it kind of ended up looking like was that many times Olympians and a lot of the better players would play at the PWHPA, and other really good women would play the PHF, and they all approached it a little bit differently. PHF would have like a regular season where you'd have sort of games and then playoffs and a championship, where the PWHPA would travel around the US and Canada and showcase games with elite level women. And they kind of were just taking different approaches. Eventually, the PHF would hit some financial struggles, and they would end up being merged in with the PWHPA and to form the PWHPL. And that was done at the behest of a man by the name of Mark Walter. He's presently the co-owner of the LA Dodgers and the Chelsea Football Club. And presently his organization, the Walter Group, they own all of the teams within the PWHL. This is sort of year one. And the idea is that over time, that ownership will be sort of sold to other stakeholders to sort of distribute that. But he was pretty instrumental in sort of legitimizing the teams, and also making sure that players, kind of for the first time, could play ice hockey exclusively and not really have to think about side jobs. So one of the first big contracts went out to Daryl Watts. She's the woman pictured in this picture. And her contract was at $150,000 a year, which is really remarkable in the world of women's hockey. And then as a side note, for folks that might be interested to see how these women play, I've also provided links. They stream all of their games for free on YouTube. And if you're in Canada, they also televise it on the Canadian Sports Network, I believe. So, thank you. That is the end of my talk.
That was so cool. There are a couple questions in the chat. One is, should we run static code scanning for internal tools and web apps?
Yes, you should. Because when we think about kind of the world of cybersecurity today, it's very different from the past. So in the past, you sort of had the idea of internal, external from the concept of a network, where your firewall was the thing that was protecting you, and maybe your DMZ and other things. And these days, that's less of a thing right now. The kind of the perimeters are like the identity, if you will, and identities can be forged. They can be compromised. And you can't assume that just because somebody's on the same office network as you, or a process is on the same office network as you, that that it's always going to be safe from an outside force. And sometimes those outside forces might not even be malicious to begin with, right? It could just be a simple bug that ends up taking out your system. You sort of get SQL injection by accident. It doesn't have to be by malicious attempt. So yes, it absolutely should be done on internal apps. And I feel pretty strongly about that. Like, there's a sort of like no just in case. Like it shouldn't matter if it's directly exposed to the internet or not.
And then the follow-up question to that is, if someone is looking for a way to start doing static code scanning for internal tools and web apps, do you have suggestions on where and how they can get started?
Yeah, I mean the simple way is whatever your programming stack is. Let's say Ruby, and you're like Ruby space SAST tool on GitHub, and you'll find a number of open source tools that'll help you get started there. And they will all have slightly different implementation mechanics. Some will function as a CLI, some will integrate with your IDE, some you have to pay for. But really something that's better than nothing. And there's an open source tool for every major programming language that exists today. So there's really no cost consideration to get started. where you start sort of having to think about other options or having to do tuning is to my point earlier, when if you already have a big code base and you apply SAST to it for the first time ever, you're probably going to get a lot of noise. So the work of prioritization is a discipline in and of itself, and is usually the work of like application security teams or other folks if it's just too overwhelming, because it starts becoming vulnerability management at that point.
And then not an SAST question, but it looked like in the photo of you playing hockey that you play goalie. Have you always played goalie, or have you gotten to switch it around a little bit?
I do not play goalie, so
Okay, I
this
was wrong.
this is me playing, not goalie. I typically when I play women's hockey, I usually play center. I'm taller. I'm
Cool.
5'11" or 180 centimeters for my European friends, and I usually confer some advantages in that position. But no, I played goalie once as a kid, and that my teams would not win if I played goalie.
Right on. Thank you so much, Julie. That was really, really cool and super informative, both on SAST and women's hockey.
Of course, thank you.